they should at least because they really not go to the book all and stuff.
What they're trying to quit. What word do you want?
Well, okay, kind of the standards in Europe are, well, okay, it's not only the French and the German, which actually are made to be their work, but there's also Italian.
There's also Swiss.
Yeah, that's not EU.
Right. But I still have to own one.
Still are EU now.
Without time. It's such a short commute.
In particular from Geneva.
Yes.
Hey, good morning, everybody. We're going to get started. We do have a few remote participants, so please be sure to use the microphone when you're making your comments so they can know what's going on. Shall I start?
Hello, welcome to the TAPS session for IETF 100. If you're not here for TAPS, maybe you can think what you want to do. You can leave or stay. So this is not very well. If you're not know what it is you can read about it online. Yeah. As I said, this is TAPS Working Group IETF 100 meeting, and my name is Jahidujaman Sarkar, and I'm co-chair to Aaron Falk. Aaron. So this is our agenda, how it looks like. So we'll have chairs update, then we have a couple of drafts that will be presented, and then at the end we have like 10 minutes for discussing on Charter Item 3. Anybody wants to bash this agenda? Yeah.
I'm willing to have my section be shorter than 25 minutes because it probably doesn't need to be that long, so we can have more time on the charter at the end. I think we should have that.
Yeah. Okay.
Any objections? Should we sit and make Tommy talk the extra?
We'll see. Okay. So the status, we have 2 drafts that we have sent in RFC editor queue. Is waiting to. So congratulations, and we would like to especially thank the authors and the reviewers of the draft. Job well done. Thank you. On the Charter Item 2, we have between the item 99 and 100, we have adopted this draft. So I think we are going to have some updates on that one. On Charter Item 3, we're pretty good, in a good situation. There are a bunch of drafts addressing it. We have these post-socket, socket intents, happy eyeballs, and there is a guideline draft on how do you do racing. And there is a new draft from NEET project, right? So we're pretty much in very good shape there. We have multiple documents addressing the Charter 3. So in this meeting, actually, we're going to talk a lot about those drafts and how we're gonna go proceed with that one. So that looks pretty good. On the security topic, I think we had an action point, so updating the charter. We have some suggested texts that will very soon will be in discussing. And there we have a survey draft. Chris, Tommy, you guys have been updating that one, and you wanted to have some review from the working group. So you want to say something more about that?
Yeah, Chris Wood, Apple. We didn't make the updates in time for the tracker, but as discussed in the last meeting, we're trying to go through and just add as many more protocol descriptions that we can to get it pretty expansive and cover all our ground. So yeah, when we do update it, we'll send an email to the list and hopefully people can read it and give us feedback and see how it goes from there. I don't know what we have to do with regards to the charter update. We talked about it during the last meeting. I don't know what the official process is for updating things, but
Next slide.
okay.
Yeah. So next slide. So this is how it looks like. So yeah. So I think we're in a pretty good shape. So let's talk about these security functions.
So we had a discussion at the last meeting about whether the charter permitted us to include transport security protocols within the scope of the abstract API. I went back and looked at it, and it doesn't specifically exclude it, but it seems like it's a good thing to have charters talk about what you're going to do. And that was the direction that we got from our area director. So I made a small hack to one of the paragraphs in the charter, and basically, first thing you do is you set up your new keyboard, and so we had a bunch of discussion about TCP Inc. because TCP Inc. was just kicking off when we were starting off here. That's not really relevant anymore, and so that's a little bit of distraction. But I had a sentence here that says, TAP support for security services provided by existing IETF transport protocols, and that's a phrase that we use for the rest of the scope of what TAPS is doing, is in scope. However, TAPS is not chartered to perform detailed analysis of security aspects of transport protocols. So we kept that original statement, which is to reassure people we're not trying to do new security stuff here, but we do want to make it clear that security-related functions are in the scope of what a TAPS API could do. Based on a quick interaction with Spencer, I got an early thumbs up for this. If the group, folks in the room are comfortable with it, we'll send it out on the list. And then assuming that there's, however that converges, then we'll go and submit that as a charter update. And now our area director has something to say.
Spencer Dawkins, responsible area director. Aaron and Zahed and I had the conversation mostly about the beginning of this, and what that would say, and not so much about the part that's going away about TCP Inc. Are you thinking? So, question is: are you all thinking that has been overtaken by events, or that there's no work to do?
I think that it's basically a subset of the work that's described in the new sentence that's added to the first, and if we left it in there, then it just makes the paragraph kind of confusing, and charters are hard enough to read as it is.
That makes even more sense to me than what I was hoping. Thank you so much.
So you're all right with that, Chris? Kyle, you got a comment?
I do, Kyle Rose. So the discussion that we had offline about there are properties of security protocols that we may need to abstract away and provide as knobs for TAPS users. So for instance, for token binding, needing to have a channel binding is something that the security layer needs to provide. Does this language preclude that?
My intention of framing it that way is to allow us to have that conversation.
Okay.
I didn't want to try to do it before writing the charter. I did want to allow it to happen in the room. Is that, ideally, if we can come up with like some general statements of how an application might ask for or interact with security functions that are integrated in the transport layer. And I think that what you're talking about with token binding is part of that. I think that this language permits that.
Okay, I mean, it's like sort of the fine line of we're not chartered to perform detailed analysis of security aspects of transport protocols. We need the security, any security layer that TAPS is going to make use of to provide a channel binding. Is that detailed analysis?
I see your point. I didn't really want to touch that earlier text because that was sort of the let's not alarm the folks in the security area statement. But I interpreted that as we're not going to try to do anything related to cryptography or new security mechanisms.
Right, that's the intent, I think.
Right. That's really sort of security design and engineering, whereas I think you're right that what we are talking about doing is some analysis.
I mean, it seems like the draft, Tommy and Chris's draft on the the survey of transport security protocols is
Kind of a detailed
an-
analysis.
yeah, is a detailed analysis.
Okay, how about, why don't we replace the word analysis with design?
Perform, well, let's, maybe think about that a little bit.
Okay, well, yeah, think about that. I mean, we don't need to make the decision here, but your point's a good one. And I would rather have the charter be correct than not touch things just because it could be a pain in the butt.
Okay.
Thank you, Amy. Go for it. Chris, go ahead.
Chris at Apple. Yeah, I was just going to say I interpret the security services as the knobs that we want to expose, and yeah, analysis maybe could be construed as potentially creating things that, and we don't want to touch that or open that can of worms. So maybe just simply say that we're not doing any, like you said, security engineering or creation of transport security things.
Yeah. So are you comfortable if I replace something along the lines of replacing the word analysis with design, and then we'll see whether Spencer gets any pushback from the ISG, and worst case, we leave the existing wording in there and do what we're going to do anyways.
Yes, I would like design better, I think.
Okay, Kyle, you're taking notes, right? Tail's not here yet. Can you write that down? Thank you. Brian?
Actually, yeah, what Chris said.
Excellent. Not sure you got something? Oh, okay. Okay. What's the next? You want to do some security engineering? You're gonna have to leave the room. Who's first? Michael? Michael. There you are. Good seeing you. Yeah, I think right up.
Hey, hey. All right. This should be smooth and easy, I hope. It's a quick update on what I did to the MinSet document. Yay. In a nutshell, oh yeah, it begins by saying also, because I changed the sequence on this slide. Sorry. First of all, one thing that I added to this document was to have early configuration so that we can avoid issues. So for instance, if you read the MinSet right now and you would say, well, okay, this is how I would implement this into service within the protocol. And let's say, let's now build a TAP system. Let's follow one of the API proposals. You may end up, making a choice for UDP based on what the application wishes, and then the application says, "Let me have reliability," and you go like, that wasn't a good thing. So a TAP system needs to have some information early to make some decisions. And there is a proposal in there on what, for instance, such a decision tree, I called it the decision tree, could look like. But this is really only written as an example. So this is not as systematically derived as the rest. Like I don't want to say I can prove this is the ideal decision tree based on all these things. It's an example of how you could avoid cornering yourself. Then people asked at the last IETF to consider also supporting UDP. And like discussing, what would happen, or like which of the things would work with UDP or not. And I've done that. And make it clear that this is not an API proposal. That was a request from a couple of people here. So I wrote very explicit text. I considered writing, "Don't be afraid of the MinSet," but it isn't an API proposal. It's just a more clearer, simpler, coherent way of writing the services up. So this is why it has this kind of form. I think it's clear enough. If you object to any of the text that is not clear enough, I can repeat the sentence three times or something. Yeah, I think it will. Okay, so the example decision tree, I'll just present it because it's in there. I'm not saying this is perfect or anything. Very happy to get feedback on it. It's just an example. But you could, early on, this would actually, at least, it seems to me, this would cover at least the things that are in the MinSet, and you wouldn't corner yourself on them. You could ask for some form of reliability. Do you need this? If no, then you could use all the protocols that are available, based on the upcoming next requests. You could then ask, is any of the following useful to the application? So this is just looking through the set in the MinSet, specific checksum coverage, specified checksum coverage is required by the receiver, then you can choose between UDP Lite or UDP. And if you do need some form of reliability, you really should be using STTP or TCP out of the set of existing protocols there. So there are these disclaimers that we call TCP, we say TCP replacing MPTCP or TCP. And if the following useful, handing over a message to reliably transfer before connection setup, that's something that, for instance, STTP doesn't do, but TCP does. Suggesting a timeout to the peer, notification of excessive retransmits, notification of ICMP message arrival. That's the stuff that TCP does and STTP doesn't. So in this case, you would be having TCP instead of STTP. Otherwise, the recur would be preferable, for setup, and then you can make your decisions. Possibly some stuff is missing. I don't know. I don't think so. I mean, I went through the list and tried to basically cover all the stuff that is in the remaining list of the MinSet at the end, and make sure that there wouldn't be anything that you would be cornering yourself against. This is just an update of the interface description. The description is pretty much the same that I presented the last time, except that I marked some things with being impossible to support UDP fallback, like doing this over UDP. This will be the configure timeout, because obviously TCP doesn't have timeouts. It doesn't have close in that form. It has some sort of an abort in that you can tell that you don't want to use this connection state anymore locally, but close comes with the semantics of a message to the other end to tell the other end about it. So UDP doesn't do that. And then the parameters of send frame, like choosing reliability, choosing ordered or not ordered, choosing idempotent, that's stuff that UDP doesn't do. And so I guess idempotent is actually a mistake, because that was about falling back, and that doesn't actually, just because you specify that it's idempotent doesn't mean that you have a problem with it arriving only once. So that is a mistake. But I think reliability and ordered, requiring ordered is a mistake. Some of the notifications, a timeout notification, close abort notifications, they wouldn't exist in UDP, and the rest is just the old slide, so this hasn't changed. So that's what that is. This was just a more efficient, condensed way of writing transport features. It isn't the proposed API. I repeat it here. The draft says it very explicitly. I did ask about fallback to TLS, but I think this answer that I got from Tommy on the mailing list, I mean, this settles the discussion in my opinion. I agree. I don't think there's a point in discussing a fallback, because it should be something that's explicit anyway. It's a choice all the way. I agree with that. Easy. Well, what else do you guys need from the MinSet? It's like just the end of it already.
Hi, Brian Trammell. Is this an API specification?
Sorry.
Sorry.
Hey.
So there's an interesting question on this slide that I think has nothing to do with this document that I just wanted to raise up and say we should think about. So there's an implicit assumption in sort of the way that you've ordered the protocols in MinSet that like there's UDP and then there's TCP and then you've ordered them essentially in order of additional features that you can get with them, and then there's TCP is the floor and then UDP is the subfloor. And from the standpoint of you have a feature set and you need to meet it, I think that's absolutely the right way to look at it. There's this second sort of externality, which is what can you get through the network, which we should think about somehow. And this, when you talk about fallback to TLS or HTTPS, it's like, yeah, you might have to go. That's like, so the order is like more complicated services with less complicated services. The subfloor is TLS with HTTPS. I'm going to encrypt it and let you figure it out. And then there's TCP and then there's UDP, right, in terms of what gets through the network.
Yeah.
That might be interesting to capture somewhere, but definitely not in this document. So I think this is getting pretty close to done. So thanks.
Okay.
Tommy Pauly, Apple. So one thing just on what you had started out with, I think that it's definitely good to emphasize that the configuration of what you might want to use out of the features does need to happen at the beginning before you end up creating things. So making that really explicit, because that's essentially something that we've learned by doing the MinSet, which is something that any API will want to build on top of this needs to take into account. Essentially says all of the feature space you want to use needs to be defined beforehand, because if you end up saying, I want to do this now halfway through the connection, that could be really bizarre. Very awkward. So Brian, did you see the email I had sent out to the list earlier today? Okay, because you essentially repeated exactly word for word what I had said about this.
Yeah.
So, and we didn't talk, I swear. Right, so I think I like the document. I think it's a very good survey of this. I think the main substantive change I would do to it is just to kind of remove all of the references to fallback, because that's much more of a normative, time-based claim about what we prefer, what the ordering is. And maybe the order is what you say. I think oftentimes it would be for feature set, but there are other cases in which we may have different preferences. There may be completely other protocols that we have in the future, like quick, blah, blah, blah. And so just for those who have not seen the proposal, essentially what I was saying was for the feature lists where we have, okay, protocol is SCTP and fallback to TCP does this, fallback to UDP does this. Instead, just for each feature, simply list, these are the protocols that implement this, these are the protocols that can safely ignore it, and these are the protocols that will not work with this. And the idea of what order we want, or even if we just choose one, is left to a later document, something like the Happy Eyeballs document, something like an API document.
I think that's more along the lines of the scope
So-
of what's supposed to be in Doc 2.
As a service to those who haven't seen my reply to that email, I'll repeat that I agree with everything. I wrote that on the list already, so it's very easy.
So Spencer Dawkins is a curious individual. I actually got up to say about 80% of what Tommy just said without me actually saying anything, which is even better than getting somebody to say something without sending them an email. This is why I'm an area director. I'm just saying.
So I have a couple of questions, Michael.
It's getting too easy.
What is on the list of things that you believe have to happen before you can say this document is complete?
Incorporate Tommy's comments, give it another proofread.
Okay, so it sounds like there's no additional content that you think needs to be generated other than the revision that we're
My
talking about.
co-author, Stein, do you have any?
Okay. Can I see a show of hands in the room of the folks who've read the latest version? Okay, so it looks like about maybe 8. Can I see a show of hands of people who have read the min sets in the last 6 months, A version? That looks more like 15.
All right.
Okay, so that looks like
Thanks.
it's people are reading it, so that's good.
Good.
Let me just ask the room, is there any comment on, so Michael making the revision that was discussed this morning, and then taking the document to a working group last call. Does anybody have any concerns about that they want to discuss? Okay, let the minutes show. Everybody loves that idea. Is Taylor here? Yeah, that's what I heard before. Oh, Gabe.
Gabriel Montenegro, Microsoft. Is there any other axis of decision other than characteristics of the transport layer? Things like, do you need this to run on a very small constrained device? The reason I ask that is that once you add that into the possible axis of decision, then other quote unquote transports may come into play, like co-op specifically.
Yeah, right.
Which from this point of view, or from a point of view of the classical transport layer, its application, but actually it's being treated as a transport in many communities. And some of those internal to IETF, or other transports, quote unquote transports like that. So has that been explicitly decided to be out of charter for some reason?
Well, I mean, so the MinSet is based on the preceding document, which is the usage document, which also relates to this RFC that gives a survey of things that we decided here to call transports. I don't know if CoAP is a part of that RFC. I don't think it is. So I think we just at some point said we're going to analyze, what was it, TCP, UDP, UDP Lite, MPTCP, LEDBET, SCTP. I think that was the list. That was just, and the MinSet is just a matter of taking what is in this other document and saying, how do you do fallbacks and which of this stuff do you really want to expose?
Okay, so maybe for a
So
second revision,
adding
'cause
another
I-
protocol is now a bit of
yeah,
a pain.
because I did hear somebody mention in the future, maybe we'll consider quick, which is obviously missing in this one, but
Yeah,
it should be added in the next revision, I suppose. At that time, it's something built on top of UDP, not very different from what CoAP can be, or,
so
you know, that, at that point, it might become
So
relevant.
my hope, I mean, this is not explicit in the document, and I would like to have at least a paragraph in the introduction saying this. My hope is that because SCTP is a very, very broad protocol that does a lot of things, that you're not probably gonna get very, very many things from newer protocols that need to be in the API that this document doesn't cover. So it might be one feature here or there, but not a huge amount. And so that's also the case for Quick. Quick isn't a part of the analysis because when Quick is still, even now, it's still a moving target. This makes it hard to analyze.
Wait, don't sit down, Gabriel.
Um,
I think that I think that the goal of the MinSet was to identify the minimum set of functions that a TAPS API should support to allow applications to get sort of basic functionality of what existing IETF protocols provide. And the idea being that if you need more specialized stuff that the protocols can provide, then you do it outside of the API. It seems to me that if CoAP is a candidate transport protocol in the way that you're thinking of using it, that a useful test of MinSet is to say, are the set of functions that MinSet says you have to support things that CoAP can provide? And if there are answers where it's no, that might be an indication that CoAP isn't really a fully functional transport protocol. It doesn't meet sort of the minimum bar of what you can do for a transport protocol. Or if the answer is no, and you think that it is acceptable, then maybe we've got stuff in MinSet that doesn't belong there. So I don't think it's, so the first step was like, let's survey all the existing transport protocols to try to figure out what the functions are, and then distill from that what like the really necessary functions are. And then we come up with sort of the template. And now if you're going to build a new transport, well, these are the things that you need to do. Well, maybe CoAP is doing that. And so it would be great to use that as a test for MinSet to say, oh, you've expressed things in a way that don't make sense to us, or there's stuff that's missing or stuff that we could never provide, but we think it's sufficient anyway. So that would be a really nice discussion to have on the list.
Yeah, going to that, the model I have in my mind is how this could work would be similar to a model applied in IRTF, like ICCRG and CFRG. They are sort of like places where you go to have crypto advice, which applies to many, potentially several working groups in IETF. Similar for congestion control, several working groups in IETF have congestion control issues. This could be sort of that source of, I guess, advice for people working on different transports. And so you should probably go off and shop or expose this work in explicitly things like core, working groups like core, and others that are working on WebRTC comes to mind, others that are working on transport issues. So.
Yeah, it's a great idea.
I agree.
It seems like maybe something we should bring up at dispatch to, what's the forum where it would have reached the CoAP folks other than you happen to wandering in the room?
Core. The core working group.
Okay.
For that particular protocol.
Is there anybody in the room who's active in that group?
Bob Moskowitz, HG Consulting, yes.
Thank you, Bob.
Actually, I look at the problem, I'm literally flipping it over. I'm really following this and very interesting. For instance, how would I run CoAP over CanFD in a car or run it over SMS? And what sort of a shim am I going to need? How thin of a shim am I going to need such that I can, the CoAP application can use this API and not know that one side is on CanFD and the other side is this CoAP server up in the automotive cloud going through a CanFD IP gateway where it gets stuck on UDP or whatever needs to get stuck on to go that way. So that is what my looking at my layering history to do this, that how is this API now going to make it possible where I'm working with Macs that can't possibly run transport for the limit, either because the PHY is too limited or the Mac is too limited or so on, you know, that sort of stuff. So does this give me, have you done this completely enough such that now we can say CoAP You don't care what the transport is. You just call this API. It's a matter of the shims underneath which make this decision. That, I think, is your goal.
So have you looked at MinSet to see, does it?
I've not looked at the
solve
last
problem?
draft. The previous draft, it was not there. This last draft, I've been very busy doing some light crypto stuff, work, but I got to get back into it, and I will.
That would be a great reality test of whether this document is.
Exactly. That is my personal view, and I'll be giving feedback along the way on this as we move into stuff.
Thank you, Bob.
Right.
Tommy Pauly, Apple. Yeah, I think this discussion's very good. I mean, I think for the purpose of this document, the focus on the existing transports that we've already surveyed is the right way to kind of distill that set. But as we go on to discuss API stuff, of course, any abstract API for taps should incorporate any of these other pseudo transport options to abstract the transport layer away sufficiently. And I could imagine essentially using this MinSet format or whatever we come up with here as a prototype for future documents that essentially define the mapping of XYZ other protocol transport or layer 2 thing as something that could be represented beneath these basic functionalities. So we may also want to think of that, of how like we could end up with like mapping documents in the future that look like this.
Yeah, be nice to have one for quick.
Yeah, sure.
Mia Kulevin. So a completely different comment. I've been thinking about how to map this to post sockets, right? And in post sockets, we have like those boxes, which all have some kind of interface. And then we also have this one magic box, which is like the configuration, right? And you have separated the interfaces you have into things that are related to connection establishment and things that are related to data transfer. But maybe it would be nice to take out of both of those categories everything that's rather something that is configuration and it's not essential to transferring data or getting the connection set up, and have like a third block in there, because that would kind of make it easier to map it to
configuration. So I have this maintenance category. That's I call it maintenance, but this is what I meant. This was configuration stuff.
What's in the maintenance category? I don't know it by heart.
Maintenance is keeping up the connection, not just establishment. It's like
Yeah, it seems like maintenance is a subset of configuration. If there's configuration that gets.
Oh, you
set
want to
before
have
you open up
all
the-
connections set up to add on. You don't want to call the whole thing configuration.
So, Tommy Pauly. So, Michael, in some of our emails about post sockets, and I guess we're going to get to that presentation next, so we can just transition. I had been bringing up the idea that there were pieces of functionality that are kind of like core transport functionality, and then I was saying and then there's kind of like the protocol specific things that seem to be fitting on the side. And perhaps I think that's the distinction that Miri is making. So like things like I want to initiate a connection, things I want to accept a connection, I want to read, I want to write. Those are absolutely fundamental things, and there are certain maintenance things that are absolutely fundamental to the live interaction. And then some of these other things, like you're saying, I want to disable Nagel, I want to do this, I want to set the timeouts. Those, like anything that you say, this needs to be expressed as a requirement before the connection gets created, is kind of that configuration bucket. So you could add a distinction there that this is something that for example, no application would need to say, by the way, I want to call initiate connection. They're all going to do that, but they will have to tell you, I may want to do this functionality, or I want you to do this functionality for me. So that needs to be said upfront as a configuration.
Right. So you need to distinguish between what needs to be set up front and not. But other than that, I don't personally like drawing a line and saying this is kind of not so important functionality. This is core functionality. Because then we're back to the old ways, right? You can send and receive, and you have maybe the things and you miss out on some services that would be good to have. Like for instance, in your example, there was the checksum configuration bit. I don't know on what basis you would say this is not a core functionality, right? This is just because it's a taste thing.
It's not really about core and being more or less important. It's really about fundamentals. So without this function, you cannot communicate. You need to call it at some point in your way through all the function calls you do. But but
then you have just send, receive, pretty much.
Pretty much I also listen, create there like this.
That's a bit of an unusual, or like I don't see the point.
The point is to map to to get the mapping between what we do in post socket and
Right,
this
but
stuff.
I don't want to change minset for post sockets. I think you should change post sockets for minset because the minset describes the functions that are there, right?
Yeah, but
So if
say,
you say these are not core things, and then you just make the minset post sockets just do the core things, that's not the right approach.
no, it's like it's not that we're not doing it. It's just like in which box they go, right? And like if we change it in post socket, it's a completely different proposal.
So I read post sockets. I know the boxes.
Yeah.
So what's the box problem?
So that there is a box which is called is it called configuration? It's called configuration, and I think it would be important to know which functions should go in that box.
Can I try to reframe this?
So we're 10 minutes over. We're going to cut the line after Gory.
Let me
It's just a categorization.
I think maybe we're not gonna convert to the-
keeping on to my tradition of restating things that Tommy has said. So I think there's a useful distinction in the distinction that you're making with respect to there are things that you need to do before setup and there's things that you need to do after setup. That's a very clear line in sort of the configuration space. It's like you cannot reselect a protocol. There are also things you do like you can't once you've decided which transport port you're going to use in TCP, you cannot change the destination transport port without having a new connection, right? So this is sort of the connection setup versus connection maintenance side. I think that sort of to rephrase what Miria said, I think that the disconnect is this is necessarily bottom up, right? Like Minset is designed to be bottom up in order to get us so let me ask my joke question again. Is this an API specification? And let me answer it. Yes, it is. It is a specification for the API in which you implement APIs that you hand off to the application.
Yes. So
Right.
this is how I see it. You could easily write post sockets
Yes.
over
Yes.
that. So for instance, right, when we say that certain things need to be known at the beginning and you just said you cannot change
Yes.
afterwards. Well, with post sockets, you might be able. You could have
Because you can you just
longer-term
create a new
state and you can just turn down a connection, open a new connection, whatever.
a carrier gets a new
right?
PSI, right? Yeah.
But like the bottom layer that you basically want to build this on is the set of the services that the protocols now
exactly.
offer, and that's what that describes.
And then so post sockets essentially any post sockets implementation is essentially an interlayer. So I don't think that there's
basically at a higher layer.
Right,
This
like
is
so
why I don't see.
it would be so I think what Miri was saying is that it would be useful if the sort of the knobs that we have here were organized in the document in a slightly better way. But like fundamentally, any post sockets implementation is an interlayer and you can, just throw another layer in there and adapt it. So I don't think we have a big problem here.
Right. I'm not religious about this, this distinction I made about maintenance and connection setup and whatever. It's so, we can discuss about how we organize the text there.
Briefly, Gory.
I think I got confused.
Not
I like
to
what
that
Michael said, and I didn't quite understand the disconnect with the post sockets, but I guess we can clear that up on the list. Yeah.
Well, we have an agenda item on post socket, so maybe we will have an opportunity to revisit that. Thank you, Michael.
I think we're in the post socket.
Yeah, I think right. We're already there. Except, yes. So, okay, Brian. Now it's your turn at the microphone, and Michael can ask you questions. There's the thing.
I have a thing? Can I actually do the thing with the thing? Does the thing work? Wow. Does this part work? Can I play with cats? Excellent. All right. Hi. I'm Brian Trammell. Actually, for my curiosity, who here has read this document? Okay, a few people. Good. So I'm assuming that you've either looked at 02 or 03 and that you're kind of up to date with this. This is not the whole, we've already given the intro to post sockets like 5 times. This is the changes. This is the detailed changes. So this is changes since 01 because 02 was, I accidentally submitted a draft that had a whole bunch of editor's notes in it that shouldn't have been in there. So it's like 02 and then like 30 seconds later 03 came out and it actually breaks the data tracker's diff tool. It doesn't know what it's supposed to diff against. It's pretty cool. So you may recall from last time we had a quick framing discussion about how scary policies are. It turns out policies are still scary, so we decided to rename them and call them configurations. Well, no. So there's actually there's a real reason for doing this. Is policy in a lot of contexts implies something that's much higher level, right? That's much, you know, I would like to have a connection that works, right? Okay, I mean, or something like this, or I'd like to have a connection that works and I don't want to use this interface because it costs too much unless I'm in this situation, right? And this is like at a much higher level than one, MinSet is, and then two, I think we can realistically talk about at this point, right? So what we can realistically talk about now are much closer to the MinSet configuration stuff. So what are the aspects of transport protocols that I'm willing and able to use? And then there's also this explicit separation where we took, so in, let's go here. This is the slightly updated thing. So this is the magic configuration box over here on the side. We put it over on the side so you wouldn't notice it. This is a protocol stack configuration, which configures a protocol stack instance, which implements a transient. And we basically took all of the things that you might want to push down to a specific protocol stack instance and stuck those in a protocol stack configuration. So you could say, for example, my configuration requires a reliable transport protocol. If you happen to select TCP, here's what I want you to do for congestion control and timeouts and whatnot there, right? So this is where the protocol specific tweaks live. So this is why I'm not worried that we can take everything in MinSet and put it somewhere. If it turns out to be specific to a protocol or a subset of protocols, we can just push it down into the PSC. There's a new, most of the work here that we actually got in for this rev is in the API dynamics section. So this is some ASCII art that attempts to show how all of this stuff fits together. This is, we used to have some examples, which were just a sketch in Go code, and I got a pull request from somebody saying your Go code doesn't compile. I'm like, that's not the point. So we basically said, okay, let's work all this out in something that's clearly not meant to compile, and then we'll bring some examples in an appendix after we have prototype implementations that we can use that will actually have building code in order to head off those sorts of comments. These are the abstractions. Like I said before, nothing much has changed here other than we've got a little bit more detail and understanding of what's going on with configurations. Does somebody want to interrupt me here?
Spencer Dawkins is a curious individual. Is actually on the previous slide, if that's okay. So the thing I was curious about here was if you were thinking that the PSC, I guess, would be something that's required, or something something that if I say I want a reliable stream and I don't care about the details, you would be able to run with that?
So there is an unwritten, in this rev of the document, there is an unwritten principle which we need to write down. So in some of the discussions we've had before this meeting, sort of in the hallway, it's become clear that there are a few principles that we've kind of had in our heads when we're designing this we haven't written down yet that we need to write down. And one of them is, if you just go here and you say, I create a carrier with initiate and I start sending messages at it and I don't do anything, it does something sane, right? So you don't have to create a gigantic block of XML or something else horrible and poke it into the association before it works. It's a hard requirement that initiate go, just like in the current sockets API. I just, I have some information and in order to create a socket, I create the socket and I go. That's a hard requirement of this arrangement. The protocol stack configuration is really, think of it as if in a current operational situation, you would go and put something in etc sysctld in order to change something, then you're messing around with the protocol stack configuration. If you wouldn't, then you're not.
Thank you. That's very helpful. What my concern was, we've got like, I don't know, 20 or 30 years of applications that know way too much about the transport.
Yes.
And I'm hoping that knowledge doesn't get stuck someplace where the application can still find it.
How,
and let me just continue to say, if your point was that the default, if you don't dork with it, will work, unless it won't work for you, something good will still happen. That means that most protocols, most applications may not end up with a lot of protocol specific knowledge that they don't need that would prevent us from doing an SCTP deployment, in not that, but in G.
Here's what we hope. We hope, and actually Tommy has a little bit of experience with this, and it seems to not be an incorrect hope so far. We have this durable state here, which holds information on a per path basis. Transport protocols generate an enormous amount of self-measurement information and can be used to essentially figure out for a given path in a given situation, for a given carrier from a given application protocol, this is the right thing to do, right? This is, so, we refer to configuration as the magic box. Actually, association is the magic box. Configuration is the box that you use in order to restrict the magic, right? How hard it is for an application to poke a PSC in, I don't think it can be any harder than etsy sysctld and set sock opt. But if we want to make that harder, I think that's probably implementation specific. You have to break a hash and give it a Bitcoin, and then you get to do something. But I didn't actually mean that, just to be clear. But yeah, so yeah, this is exactly our goal. Exactly our goal is to obviate the need for a lot of this digging around with socket options, because what you get by default is just better.
Yeah, and thank you for a very helpful answer. And that's just because you said what I was hoping you would say, that doesn't make it right. But that you said what I was hoping you would say. Thank you.
Cool.
Tommy Pauly, Apple. Just to that point, briefly, I think one thing that Brian said is I think it's key for these protocol stack configurations is that I think it needs to be expressed in the API that this is, if you use TCP, set this weird, wacky option. If you use SCTP, and I think it would need to be clear that TAPS may choose whatever it wants, and these are just extra knobs if you're a weird, geeky TCP person.
You could certainly put something up in the configuration that says use TCP.
You could.
Right? So if you are a one-sided, and this is another one of those principles that we've not articulated is, it has to be possible to use post sockets on a single side of a connection and have Berkeley sockets on the other side of the connection. So in that case, either TAPS will look at the association information and figure out, oh, okay, I'm not dealing with something on the other side. And another principle that we have is that you shouldn't have to implement, you must not have to implement transport protocol external signaling mechanisms in order to make this work. This is not like dynamic network stack negotiation. Because every project I know that's tried to do that got to the dynamic network stack negotiation part and said, oh, look, we're out of money, we gotta go. So another one of these, and that would basically, if you're really in the situation, that you're in that situation, you're always going to be in that situation. You can always just poke something down into the thing that says use TCP. And again, it's probably implementation specific as to how you express that, whether you have to trick it into doing that or whether you can just say, like with GetAtter, like the old GetAtter info hack where you had to GetAtter info and then poke IP proto SCTP into it in order to get it to do SCTP. Yeah, I mean, this is the magic box because that's the place where we put to do all those tricks.
The one other thing I actually came up here to say as an author, another change in the draft, just for people who are reading it, is around messages and the fact that because we like the message distraction, but there's the whole problem with streams and if I'm just going over plain TCP, what does my message mean? And the solution that we came to there was that each side of a TCP stream is just one really big, long message. And so it means that the API for reading and writing messages may come in multiple chunks. And it'll just say, at some point, this message is done. And it's kind of degenerate, but it allows us to put everything under that umbrella, right? Without having to have another layer.
we had this other hack before that was worse. So this is the better hack.
Praveen Balasubramanian, Microsoft. Protocol stack configuration, right? So if this is part of the API surface, there will obviously be system policy as well, administrator configured, for example.
Right.
How do you reconcile those two? Are both of those expressed in the same way? The other question I had was, is this an abstract representation like reliable semantics, or is this the application allowed to say, I want to use TCP? So which way are you leaning towards?
So this is an abstract API. So we hope that concrete implementations of this are going to have compatible representations of configurations and protocol stack configurations. How the reconciling happens is, that goes back to my TAPS, the IETF 99 presentation of the jokey answer is it looks a lot like cascading style sheets. In that you have within any given system a defined hierarchy of which overrides which, and then you just blow through the hierarchy and you get an instance, right? So there's, hopefully we'll have inheritance rules that are less inscrutable than those used in CSS, and I think we can get there because a lot of the externalities aren't the same. But they the point being is that they essentially cascade, right? And as long as that cascading is predictable, and I think that is something that we're going to have to drill down to on this abstract API, is we're going to have to make a choice about how that cascading works.
On the abstract front, there might be applications that actually do not want the API to be abstract. So we might have to have cases where, for example, the application explicitly chooses its, for example,
Yes.
TCP or Quick, right?
You close the line.
Yes. Yeah. We're going to stop this discussion in 5 minutes. So you guys can fight it amongst yourselves, but we're moving on.
So I think just the main point there is the abstract API should make it possible to do any of these protocols. I think it is absolutely necessary in some cases that they could say, I only want this one. But the bigger point is that if I want to reuse my code for using transports in other places, I don't have to rewrite it entirely to say, now I want to go over this other transport. I just flip the bit to say, now I want to use this one instead of this one.
Yeah.
Thank you.
Cool. Yeah, let's take the rest of that one to the list because I want to blow up the charter in a second.
Kyle Rose. So I think you answered the first question I had, which was you're not putting protocol configuration into two buckets, one which is generic and one which is specific.
No.
So you can, you could potentially have something where you say, whether you're using Quick or TCP, I want to use a particular.
Yeah. So that all goes up here, and
Okay.
the things that basically it's like, should you choose to select this protocol stack instance, then give this protocol stack instance a pointer to this information. This is very low level and should remain obviously so. This is higher level.
Okay, so two other quick points. One is around predictability. So there's, when you're running a worldwide service that has specific, reliability and performance targets, right? If there's too much magic and you can't predict exactly what the system is going to do, you might run into problems that are hard to diagnose. So the more magic you put in.
That's a really good point. Can we take that offline? Because that's going to be like half an hour.
Okay. Yeah. And the last point I had was sometimes you want to override the magic in a non-obvious way.
Yeah.
So, during the hackathon, we were trying to do an experiment on AQM to decide, decide whether ECN was providing benefit or not, and we could not create buffer bloat, right? We tried,
Yes.
and eventually we succeeded, but it took a long time.
The intention is if you know enough about which protocol stack instances you're going to select, you can basically, and those protocol stack instances are implemented in such a way that they give you that knob, then you should be able to get to it.
Okay.
Yeah. So it's up to the protocol stack instance implementation as to whether it wants to let you bloat it. So I think all of this still is correct. We're basically working on details now. There are some of the things that are details are things that are implicit in the minds of the authors that should be explicit in the draft. We're going to write down some of those. The two things that we have on our list to do beyond just general document improvements are we need a simple protocol independent carrier state machine. So this is basically the state machine that defines what happens to the carrier when it's not bound to a protocol stack instance. Because once it's bound to a protocol stack instance, that protocol stack instance's state machine determines what goes on. But you might have a carrier that has lost all of its protocol stack instances, and is trying to reconnect, or is in a particular state where it's still racing. Tommy will talk more about that. The second one is exactly right. How do we represent certain transport-specific interactions in a generic way? We don't want to be in a situation where we have two transport protocols that have never retransmit semantics. So this is a thing that's outside the min set, right? I have a partially reliable protocol and I want to tell it how to be non-partially reliable, or how that partial reliability works. And so SCTP-PR has this never retransmit semantic. How do we represent these sort of specific tweaks in a generic way. And that actually seems like we're going to have to do some work that looks a lot like the work that was done in min set, and it's like above min set, right? So it's the things that are outside the minimal set, but still at that level of abstraction. And whether or not that's something that happens in the abstract API or something that we say, okay, well, this is something that we put off to concrete configuration. So we have some open issues. The draft's on GitHub. The issues are here. If you read it and have a specific, we take pull requests. If you have a specific comment, please bring it up on the list, and we can put it in the issues, but feel free to file issues against it as well. The question that we're going to actually probably talk about later is it time to bring this work into the TAPS working group? Here's our view. There's a whole bunch of abstract PI, not application. No, these are not APIs, but they're APIs, right? We have a whole lot of these. Here's how we think all of this fits together. We have the requirements basically come from MinSet. That's the set of things that we can use to implement these abstract APIs. But we think, obviously, and I think it should be obvious in the design of post sockets, we think it's time to take a creative leap beyond that in order to be able to do, to have a transport layer API that gives us, the advantage of the 30 years of experience that we have in this space. We don't want to collate the existing options in the least bad way. We want to go beyond that. We think that creative leap is some combination of these, right? Obviously, we think that post sockets, where we think the strengths of post sockets are the interface that it provides up. Other proposals have strengths in how that should be implemented and how that works down. And we think that combination should happen within the working group, however that happens.
So I think what you're phrasing is pretty clearly not captured in the charter. So I think you're proposing a charter change.
I might be, but
because the charter item number 3 is about experimental support mechanisms. You're not describing mechanisms, right? You're talking about an architecture. We
have time to talk about this later, right?
So think about that. And I think I could be convinced either way, but my first blush, it doesn't seem like a mechanism. We're out of time. Can you make a quick comment?
Nacho Solis, LinkedIn. On that exact topic, on requires come from MinSet, it seems that sometimes we're kind of trying to say, we in the past have done the right thing, and we're prescribing what things should be done because we have MinSet. But at some point, our users, whatever is above us, are the ones that are saying, hey, can you provide this to us? Whether that is, that's what we're trying to capture with this creative leap, right? Or some other way. There's something else that is max set or something else. Now, I'm not saying and approving that everything that every user requests is the right thing to do, but we should consider whatever our higher layer is wanting us to do in what we deliver.
Absolutely.
Now, I'm not saying that this means that we still need MinSet kind of to describe what the general set so far that we have observed.
So let me rephrase that slide then. So requirements come from the layer above. The degrees of freedom we have to implement those requirements come from MinSet.
We have decided to limit ourselves in whatever shape or form. Whether we should, and even if we decide to limit ourselves, just state that somewhere.
Nope. This was a quick comment. Thank you,
Anyway,
Nacho.
if we decide to limit us,
to think about, we may come back to this.
Wolfgang Beck. The more I think about it, the more I question the possibility to abstract away from the transport layer, because we can't even do it in the IETF. Whenever we have a new application, we have endless discussion whether to use UDP, TCP, SCDP, Quick, or something else. And now we are trying to pass this task to an application interface, and I don't think that's viable. It didn't work for the original sockets API. I don't see it working in any of the approaches we see here. So.
I respectfully disagree. Thank you for your comment.
Yes. Michael Wetzel. Thinking about why this isn't in the current charter, the reason the charter is why it is the way it is, and it became so conservative, is that we had these ups and downs of people saying you want to be top down, you want to support applications, and then actually not being able to agree on anything on that basis. And what the charter now offers is something that you can implement. Now, I would agree that this is, I would agree that it's better to have a higher layer. So I mean, this is what I like about postsockets, that it tries to have a higher layer of it and represent things in slightly different ways. However, I am very concerned about the implementability of the things there. I mean, some things can be implemented, but when I read the document, it gave me many hiccups in the sense of, oh, how is this going to implement? I mean, I said you would need a system on the other side. That's because there were many sentences in there that said you couldn't actually implement this unless you have a system on the other side. So there are many sentences in there that need fixing. Many statements that things just wouldn't really match and couldn't really be implemented. And I think if the MinSet is defining what the protocols now offer, and I would hope that this matches what future protocols offer pretty much, mostly, I would be, give me any service that Quick offers that an application needs to choose, except for certain security things, right? That isn't the MinSet. Any. It's not easy to find much that really you would have to have in the API.
We look forward to working through those hiccups
And
with you on the list.
so
We have
my
moved into a
point is
discussion
that
of a charter revision that is not currently something that we're going to talk about. So
Yeah, but
we will need to revisit this.
So
you made
as
the point,
input to
Michael.
as
Please
input
move
to
on.
this document, I mean, what I want that document to do is to be able to map down to MinSet, which is something you can implement, so you can actually see how this is implementable. And yeah, I mean, the discussion goes in this direction, but the document doesn't currently match that. So it's just I give this strong input.
I'm closing the microphone. So
Yeah, I'm just
Philip,
saying that.
we can come back to this at the end if we have any time left. Where's Philip? Philip, please.
Hi. This is the second revision or 0.1 version of the socket intents draft. Before we start, I will give a quick overview of what socket intents is and what the basic idea is. By the way, who has read the draft or some earlier version of it? Okay, quite a few. So this revision of the draft was basically for reshaping it that it better fits within the overall ecosystem and really it makes clear what piece it is, where to fit it, and what it's supposed to do. And it's essentially an input for automatic transport option selection or automatic transport selection. So it's an input for that magic configuration box Brian stated for post sockets, and a way to express stuff in there. It provides inputs on the application needs, so whether an application wants to optimize for bandwidth, latency, or cost, whether it, how the traffic characteristics are, how it tolerates packet, data, or connection loss. So beyond that, I want reliability, the part of whether my carrier or my connection breaks down. Is this a real problem for the application, or has the application semantics on its own to say, oh, just it was an HTTP download, I'll do a partial get after the next context. I don't care about my connection being lost. So you can choose a path that might break down. I don't care, just do it. And also stuff like cost preferences. So saying, oh, please don't take a path that is really expensive. And so this kind of input should help a system like post sockets or the policy that is somewhere sitting behind it to do a sensible choose of path, to do a sensible choose of transport protocol, a sensible choose of endpoints. That's the basic idea of socket intents, being that kind of input. So for 101, it's really are pieces of information to tell the application what they know about their own communication, what they really know, and it should be intuitive in a way that it's not in the terms of the transport protocol, not in the terms of what I want to set as a flag on the transport protocol, but in the terms of the application developer. I'm going to transfer about a gigabyte over the socket, or I want to receive about a gigabyte of the socket. It should be somehow generic, that it's not bound to any transport protocol or not bound to any application semantic, but really in a way that could be done by many transport protocols, by many applications, can be reused by many applications, and it should be completely protocol independent. And the last part, this is I highlighted this time because it's exactly what Brian told about the post sockets. It's best effort. So if you specify a whole bunch of intents and saying, oh, my application wants to have a carrier that is as reliable as possible, and I don't like connection breakdowns. If there's only a path that might break down, you still get a path that might break down. If there's a path that might less likely break down, you might get the path that's less likely to break down. So this policy behind that should try to match these intents, to match these choices by the application, but it just only has a transport that doesn't match the choices. Oh, well, you get the best that's available. And the basic idea about this is it should be standardized, but it's an extendable set of hints that could be used for the transport option selection. So instead of having for each platform, for each API, for each implementation, some other kind of bunch of keywords to tell the transport option selection or tell this policy thingy what the application is going to do, you want to have one standardized set. And if you move over from programming in Go to programming in Rust or programming in C, it should be the same set of keywords. It's expressed in a different way for a different language, but it should be exactly the same set of keywords you already know and you can look up at some central place. So how does this integrate? We did an implementation as socket options on BSD sockets, which turned to be out a nice thing to see that this actually works, this concept of socket intents, but it also turned to be out not so nice in how useful it is, because you can only do it on a connection level. So you can't say, oh, I don't care about the delivery of this message, or I can't say, I want to do something like HTTP connection caching, and therefore I have two TCP connections, one over LTE, one over Wi-Fi, and specify that this message should be low latency, this message should be high bandwidth, and then it gets magically matched to the right TCP connections. Something like this you can't do with BSD sockets, but you should do with another transport. So therefore, socket intents works with BSD sockets, the terms work with BSD sockets, but it's not as useful as it would be with something like post sockets. In post socket, you could just use this as address configuration, which was in the last draft. I'm not sure whether it's still the name in the current draft, but we can take this later. Or you could specify it with a needs as a need property. So it's the concept within the system, but you can take it in any, should take them in any system that you like. Already told this could be applied to messages, streams. Streams is what the post-socket people just called carriers. Associations, what they just called associations. And association set, which is something above this, which bundles a bunch of associations. So how are they represented? So it's pretty simple. They're just key value pairs. You have a key, just a key, a lowercase ASCII string, something simple, something to remind, which I guess should be best kept in the IANA registry sometimes, somehow. But I think that's an interesting discussion item. And have a value, and the value should be have some fixed type. So either an enum, if it's kind of category, integer, float, string, or sequence of one of the above, if this is needed. I don't have a use case for the sequence yet, but it might be useful. The initial types we used were a traffic category, which is an enum, and it's applicable to streams, associations, and association sets. The size to be sent and received, which also makes sense on messages. The duration of a stream or some other transport. The bitrate sent and received, which also makes no sense on a message. How bursty traffic will be, which might be interesting if you to decide whether to schedule something over Wi-Fi or LTE if you want to save energy. How timely the delivery should be, so whether you rather want so something like TCP NAGL disabled, or whether you want a low latency carrier. How disruption resilient the application is. So whether you care about flaky Wi-Fi or rather want to be scheduled on a more expensive LTE connection, but that has a higher likelihood of not breaking down. Or the cost preference. So whether you care about, whether you think your traffic is so important that it should be carried over something like data roaming, or whether you say, oh, it's an operating system update. We can do this at the moment when we have a cheap path available. So in this case, even telling the socket API, if you don't have a cheap path available, just deny this request. Just fail the creation of the connection. It's fine for me. So with this, I'll come to the questions after giving the basic concept. So is this interface or this idea easy enough that it could be useful for an application developer and could be useful as an input to a transport system? Is the structure sufficient? Can it express all functional non-requirement performance preference? Because you can't use this to communicate, I need a reliable channel, because you need a reliable channel. If you need a reliable channel, and then the transport system can't give you UDP. And what intents, what kinds of information are missing to make this useful? That's the first page of the questions.
Michael Weitzel, there was at least one thing on the previous slide that would never arise from just analyzing the transport protocols, and that's actually something that was a bit of a concern to me when we started with this analysis, that you might miss out on some things that seem important, like burstiness. I think could be important for making a choice on the path that you want to use, or on some choices that the tap system is going to make. But it wouldn't arise from looking at what the current transports offer, right? So I'm wondering if, I'm wondering what you specifically do with burstiness, and I'm wondering if there are more of these things that we should have covered somewhere as features that actually don't, you don't get from just looking at what the protocols offer. Because this isn't the request, this is describing the application's traffic behavior.
Wolfgang Beck. You know my opinion about automatic transport layer selection, so I won't repeat that. I guess this is far too complex in the application layer, because the application has to guess what the network, what the application interface is doing. And I don't know what is burstiness. We have to explain that to an application developer, and this is hard. We've seen it 20 years ago with ATM. You had to fill out a form like this. What's your bit rate? What's your burstiness? And people never got that. And I think it would be better to expose the attributes of the underlying layer to the application, and let the application decide how to do with that. If you tell the application, okay, this is an LTE link, which might be costly, the application can decide, okay, I'm now using a simpler codec or something like that. So, instead of leaving it to some lower layer.
I also I'm happy to disagree with this. I think the big difference between ATM and this is, here the application tells what it knows. So it knows whether it will send bursts of data or whether it sends is
So what it's
rather smooth stream. So if you're doing something like HTTP streaming, it will have its bursts, but it will mostly stay at its data rate. If you have a protocol like machine-to-machine communication, it will most likely just have either small bursts or will send a few small messages. It's not about the exact burst rate. It's not about the exact bandwidth you're using. It's just about saying, oh, there will be rather big bursts. There will be rather small bursts.
So take bitrate, for example. What's the bitrate of the Opus codec? If it's a variable bitrate, I can give an upper limit, but it's not very useful because it won't reach the upper limit very often. So bitrate received, I don't know. So for some codec like this. So.
If you have, so again, let's consider a service like YouTube. You rather know how the bitrate of the video is you're requesting, or you can know this, and then you can tell it to the transport. Whether you then later on have to decide to switch to a lower bitrate, that's fine, but then you can still tell it to the transport, oh, I switched to a lower bitrate, I expect a lower bitrate on the transport. Whether this is really of a use for the transport in this situation, in the current configuration, the application can't know.
So, but the application has to know what bitrate is possible, so it can adapt. For example, YouTube will choose a different codec or lower the codec bitrate if it experiences some congestion. So my point is, expose the attributes of the underlying layer to the application and let the application decide. End-to-end principle.
And my point is, if you really want to do, if you go down that road, you end up with all applications having to know all transport protocols they might potentially use and to know all the knobs of that. But I think still both has a valid use case. I think if you're at the point where you have an application that you have exactly tailored to a transport protocol, then it's much better to expose the attributes of the transport to the application. If you have an application that doesn't want to invest too much of the engineering into this part, then it would be nice to have a layer to take care about this problem.
Praveen, Microsoft. One of the things I see missing here is there is no intent expressed for the send or receive pattern. I think transport performance could be improved if the socket intent would say, for example, what the sending pattern is. Like, for example, 24K sends, and then I wait for a message from the other side before I send again. Some pattern like that expressed to the transport, you could automatically do intelligent, like, disabling of niggling or figure out your delayed act strategy and things like that. So I think having an ability to express intent of what's the pattern would be extremely useful.
Thank you.
That's a great idea.
Yeah, +1 to that. Tommy Pauly, Apple. So, I mean, thank you for presenting this. Thank you for doing this. I think it's a very difficult area to get right. I very much agree that oftentimes we're going to need to just expose the protocol knobs because that's really what, at the end of the day, is there. So when we look at this kind of when we were talking about with post sockets, we have the configuration, which is like this generic thing, and there's like my protocol specific configurations. I think, the protocol specific configurations are what we historically think of as socket options for that one transport. These things are things that go into the top level configuration in this great generalized world. I think there are some things that are in that category. I think you mentioned, like, I don't want an expensive path. That's one of the things that we have been able to bring up into that top level configuration, because you could say, I don't want cellular, I don't want this particular carrier's network, and because you know that, but oftentimes people really just mean I want something general. So I would love to see us work on this as a working group, and likely it will tear it apart, and most of these things like bitrate may need to be stripped out or something, but I would like us to have the conversation, because this comes up all the time from people who are doing implementations of, oh, we want an abstract way to do this. And I think it'd be great to come down on each of these and some of the other options and say, kind of definitively, this is something that can be expressed abstractly. This is something that can't, and get our story straight. And so it may end up being a very difficult discussion and a tricky process, but I think we should go through it.
So I just want to insert myself into the queue here that a question for you, Philip. Have you implemented this?
So we implemented this on top of BSD sockets, but to be honest, the only policies we really used was the traffic category and the send and receive size. This is the only stuff where we really have experience and we really have evaluations on.
I think that is an excellent point, which is sort of harkening back to the ATM discussions. There's been many decades of categorization of what applications want from the network and what the network can give to the applications. And I think what we have an opportunity to do here is some experimentation in that the whole idea of the TAPS API to allow you to mix and match transports based on app indications is we may actually be able to make some progress here. But I think that this table is a little bit of an attractive nuisance in the sense that many people have seen tables like this in the past and they weren't believable then. But I think that the real test is going to be what we can implement and turns out to be useful. And I think Tommy's making a good point, which is, let's view this as a work in progress, see what works, what doesn't. Maybe some rows of the table will leave, maybe we'll add some new ones.
I think the intent of this table is really start a discussion. It's not that I want this table in the final draft.
It's the strong resemblance to the ATM traffic classification table. I think that is sets people off, at least for me.
Yeah, I think that and the RSVP stuff. Colin Bagnes. So yeah, the table makes me nervous, and this table makes me nervous. And when you start trying to categorize application behaviors, it's very easy to rat hole in a far too detailed way that goes nowhere useful. That said, if we're building these sort of generic APIs, there would seem to be a scope for passing in something about what the application knows about the data it has to the transport. So I think we need that ability. I'm unconvinced about how we do it, but I think we should at least think through that this is a feature of the future APIs.
Aren't there some semantics that come from the AVT world that might have something to contribute here?
That world, I think, is really good at going overly detailed and producing unusable things.
Not to Souls LinkedIn. I'm still grasping my head around a few of these things, but the first thing is talking about intents from the previous table that you had. Some of these things, if I read it correctly, is what the application or whatever box is above this layer intends to do, right? So it tends to send so much, so it's kind of communicating, this is what I'm intending to do. Please feel free to optimize maybe around that. Some of the things that you had in the box are not things that I intend to do, but things that I want the system to give me. So I don't think those should be mixed up. So the example would be timeliness. You intend to be timely? You don't intend to be timely. You want the system to give you some type of timeliness. Well, you do intend to be bursty, or at least you expect to be bursty. And I think in the draft, the wording changes once you get to those descriptions. So I think we should be careful to separate things that you're intending and just hinting at what you plan to do versus things that you want the system to behave. Number 2 point, and maybe more abstract, is both for these things and for configurations that you're giving to a system, in this case, this one in particular, if the system is to make a choice and do something for you, it's because you're asking or presenting a trade-off, right? I'm not going to tell the system, please perform the best possible. I'm hoping it'll perform the best possible. That's what I'm intending to do. But if I tell it that I want things to be, in this case, bandwidth, is because I want you to make the trade-off for me. Give me bandwidth versus latency, for example.
Yeah.
So at all points, in all situations, you're expecting whatever you're asking to have a cost. So we should be clear when we're describing what costs you're expecting to potentially pay by requesting something. And this should be reflected both in configurations for this or for anything else that we're doing, right? Obviously, otherwise, all applications will request, give me the best service possible all the time, right? That does not help us, right? What helps us is somebody telling you, I want bandwidth, please sacrifice these other things for me to optimize for bandwidth. And to be generic, obviously, if you want a bunch of these things, then you could have like weighted averages, like 50% bandwidth and 30% latency and 20% reliability, whatever, right? So you can come up with weird systems. But just be clear that we're asking for trade-offs, and that should be reflected in the documentation and in the APIs that we design.
That's a great point. Let's cut off the line after time.
Mia Kuhlmann, I can't agree more to Nachos. That's absolutely right. And also, I'm wondering how much of these things we actually have to specify somewhere, because it really depends on what protocol your interface supports. Like if the only protocol you support is UDP, then much of this is not useful. If you invent a completely new protocol, you need something completely different. So I'm not sure what makes sense to specify here.
I must say this, a lot of this attributes comes rather from the path selection ideas than from the question of protocol selection. So I think most attributes only make sense if you want to decide which takeoff to trade for a path, not which trade-off to take for a protocol.
Also, your implementation of path selection can be very limited, right? If you have exactly one interface, there's not much selection to do.
Yes, then
Come to Path-Aware Networking, Thursday afternoon. Hi, Brian Trammell. Can you go back to the ATM table again? So everything Nacho said, plus, so I think there's this, you're gonna take that, what are you doing? Okay. Yeah, okay, so this here, there's two issues with this. So I like, the farther to the right you get, the happier I am. The farther to the left you get, the less happy I am. Yeah, and then like from the out in is kind of like this sort of a heat map of how I like this table, right? So I think there's a problem. Okay, so you start trying to solve the problem of how do we take intents and express them in a way that you can do path and transport selection, which is mixing two things together that maybe shouldn't be mixed together. And like expressing it this way makes it clear to me. So I've also in my thinking, I've been thinking as a path and a transport stack as potentially partially equivalent. And this really underscores to me that that's wrong. And we need to go and look at post sockets and make sure that we're good there. The second thing is there seems to be this, we have this started from a concept. We'd like to be able to take some intent-based thing and use it to poke it at the transport stack and have it do something nice for us. And this looks like it drilled all the way down to the bottom of that problem and kept drilling a bit. And when it before it hits the ground, it's doing really great stuff, and then it hits the ground, and then so finding the ground there, I think, is a really important thing to do. And say, okay, we go this far, and then we stop. And I don't know where that is, but I think that this work is most useful when it's higher layer and gets more problematic the more lower layer it gets. Because this also goes to sort of the discussion we were having in post sockets about granularities of configuration. And I think there are two extremely distinct viewpoints that are represented in this room, who I will call application chauvinists and transport chauvinists. The application chauvinists are people who just want the transport to do something. I just want to write something fine, and for the most part, they don't pay attention to us anymore. They just use ZMQ and like wave their hands wildly when people ask them security questions. And the shape of the APIs that we've produced are from a very transport chauvinistic area. It's like, we're not going to trust you to do pacing because you'll nuke the internet, right? It's like there's still people who are very scared about user space transport stacks because they believe that this root user space or root non-root user distinction is useful for security, which it just isn't. And I think that this really has shown that we need to kind of try and find the balance there, right? Because this is a very application chauvinist way to do it, but does it in a way that like selects I'm an application chauvinist, by the way, so I'm with you on that. I think that we should give application developers the things that they want, not the things that we think we can give them. Yeah, actually, you know what? I'm going to take the rest of this offline because we should get moving. All right, cool. Thanks.
Let me just paraphrase a piece of what I think you said, which is I think that implementation experimentation of this stuff is going to be critical because we don't really know what's going to work and what's going to be useful.
Nothing to do with what I said, but I agree.
David Skenazy,
That's
Apple.
how you know when you've drilled too far.
So let me come back to the point of experimentation. So we did experimentation really with this send and receive size, and we found out that it really helps, for example, to decide whether you want to do HTTP pipelining on a specific path or whether you want to do multi-path TCP. For this kind of decision, it really helps. It only affects about 5% of the use cases we really had where it made a difference. In 50% of the cases, it was just doesn't matter. And 50%. So therefore, I think both parts I can say it is useful for these cases. For the other ones, I just cannot tell.
David Skenazy, Apple. So I'm going to introduce the third type of chauvinist, which is an engineering chauvinist, which I am. And it kind of reflects what you two were saying. I think there's value in creating a framework for socket intents, saying like, this is what a socket intent is. Maybe have a registry, an IANA, or here's where you put your new socket intents when you come up with them. I think there's value there. Traffic categories, those have been implemented by OSs for decades. Those have been proven to have value in some cases. And apparently you're saying this has to be sent and received as well. And in that case, I think it's great. You can document, here's how you specify those, and here's an example of how they can be used. Here's how we're using them, you get these benefits. The other ones, I would really recommend against specifying these things because you're like, oh, here's how you specify burstiness. And everyone has a way to specify burstiness. No one specifies it and no implementation does anything with it. So I think it's premature to have a laundry list of all the things we could possibly want when we don't know what to do with them. I really like Praveen's example. That I think you can act on, really messing with the delayed ACK and like how you play with Nagel. That's actionable. That's something I can write code for. How bursty you are, as someone in the TCP is like, what am I supposed to do with this? So I would push against try to standardize things that we have no idea what we would use them for.
Corey, the line was closed. Is it quick? What?
Yes, it can be quick.
Haha. Oh, yes, it was quick. Yes, I get it.
Yeah,
So
yeah.
nifty.
Thank you. Okay, so I look after RSVP stuff. I look after diffserv stuff. There is stuff in between, and it'd be really nice if the transport stack sees some of this. But do you know it's really better when we see binary things? I want low latency. I want low cost, or I want zero cost. I want. I am very, very bursty, but just not get into the details. So I like the list. I think the list should be bigger, but I think the data type value should mostly be binary.
I think the data type should be enums. Choose this or this. Bandwidth latency.
I think the last question I had is better for the last chartering and discussion part.
Yep. Thank you. Who's next? Next is Tommy.
All right, I'm Tommy. I'm going to be talking about another aspect of kind of I'd say the guts of a TAPS implementation. Hopefully none of this ever gets exposed to anyone, but it's very relevant for how we actually make a system that can try multiple options actually happen. Whenever we're talking about trying multiple paths, whenever we're talking about trying multiple protocols. Colin. That's very quick.
That is very quick.
My goodness.
It's a sort of scoping question, I think, and maybe you'll get to this. When you say racing, do you mean happy eyeballs or do you mean things like ice as well?
I'm coming from it from the happy eyeballs side. It's so I'll explain. So let me get to the next slide. I think I'll define the scope, and people have brought up the term, is the term racing the wrong thing? So we can have another term for it, but I didn't want to use happy eyeballs because that's really V4, V6 dependent in people's minds.
Yes, yes. It's just that when you say should be hidden, for happy eyeballs, I would agree. For ice, probably not.
Fair, fair. So I did this particular thing as a draft update to the TAPS guidelines document I had done last year. It included, among other things, this generic racing guidelines, and I kind of just stripped it all out to just be that part because I think everything else is captured elsewhere in things like post sockets. So this is a much more focused document. It is trying to generalize happy eyeballs, so that's kind of the angle it's coming in on. So happy eyeballs is RFC 6555. That is, now we have a BIS for that in the RFC editor queue, so that will soon be a new RFC number, which gives a little bit more advanced algorithm, and it has certain aspects that I've incorporated into this document as well. And then also this draft is trying to take a little bit stronger stance on saying that there are things that you really should do when you're building your options for how you're doing connection establishment racing. And so these are intentionally things that I want to discuss, and if you think they shouldn't be a should or a must, please let's have that discussion because I think they can be very important. So what is a connection option? I think that gets to what Colin was asking. I'm referring to that here as a tuple, 3 tuple of your endpoint, your path, and your protocol stack, which may be your protocols, your protocol options. Let's say I have TCP and TCP using TFO. I would consider those 2 different protocols, right? So we can distinguish those just based on options. It defines a notation for how we can essentially look at how a connection is established. I view it as a tree. Essentially, the point of that is that it has a hierarchy of how we look at deriving these options. If you just took all possible options and built them as like one big matrix, like a 3-dimensional matrix of multiplying all of these things, not all of those make sense. If I do a DNS resolution on Wi-Fi, I probably shouldn't just arbitrarily assume that that endpoint that I resolved works on another interface because maybe it's a local resource. So this is an attempt to cull down that space of options. So what are the ways that we have options? So we have path branching. We can select path. We can protocol stack branch, and we can do endpoint, which I'm calling derived endpoint branching, because there's always the endpoint that you have at the beginning that the application wants to get to. We better have that. But there may be stages such as bonjour, service resolution, service discovery, or just normal host name to address resolution that can be happening to generate new sublists of endpoints. Yes?
Is, say, VPN full, splitter full VPN, is that a path?
Yeah,
option
so
or a
those are
derived
paths.
endpoint?
That would be a path. So another term for path, for people who are in PVD discussions, is a PVD. So a path is not just a full interface. It's essentially just a self-coherent set of routes. So a split tunnel VPN definitely falls into that. Yes, the derived endpoint I choose may drop me into a different path, but these are more about which, like when I'm making an explicit choice at the beginning, do I want to say I want to force this attempt over a certain interface, or do I not care? So the document kind of is saying like there's a should between the ordering of these, that certain things like a resolved endpoint coming from one path probably shouldn't be used on a completely different path. So that I think is a pretty strict one. Similarly, if I have an endpoint that I have derived that's very specific to a given protocol, let's say I have one protocol stack is using a proxy and it has a new endpoint because of that. That endpoint probably doesn't make sense if I'm not using that proxy or not using this protocol that requires a different port. So I think those are very clear. We've been having discussions with some of the neat folks. I think the distinction between do I branch for path or do I branch for protocol stacks first is a little bit more flexible. I think it becomes simpler if you choose generally which big path I'm going over first, but that is maybe more of just a recommendation rather than a must. Yes, Colin.
Hi, Colin Perkins. Is V4, V6 a path or a derived?
So when I think of paths as PVDs, and in that regard, you can have your V6 and V4 kind of bundled as this is like a coherent set of things you're doing. Yes, they will certainly have different properties. I think I would agree with you that when we once we've actually connected and we're using our path properties, the path is definitely different between V4 and V6. But when we're talking about the intent of the application to try two different path options, saying that I want to try the V6 or V4 option doesn't really make sense until I've actually done my resolution. Do I even have an address for V4 or V6? But saying something like I want a VPN or I want Wi-Fi or I want cell or Ethernet or something, it's something I can say up front.
Yeah.
Sorry.
Okay. Yeah, I guess that makes sense. I'm still trying to think how it fits to a sort of net traversal style where you're trying to find sort of interfaces, protocol configurations that work. Sorry. So I'm just trying to figure out how it fits with net traversal and when you're racing different options there, is that a path or is that a derived endpoints?
Right. So one thing, I'll move on quickly, but one thing I want to point out is that when I'm discussing this is all about kind of the initial connection establishment. So not necessarily talking about the net traversal for ICE, but like for things like MPTCP, I mean, which, ultimately we will be using multiple paths.
Yep.
This is the algorithm that you're using essentially for the first leg. Just say, can I get any packets out? Once you can certainly use more paths and more addresses later on, and I'm sure that doing ICE stuff will end up using multiple things. This is about just like, does this thing even work?
But the ICE stuff is about determining that. The ICE stuff is about determining whether it works.
Right. So I think this is an area that we do need to explore more in this. So
Yeah.
I would like a review from you.
Yeah, I think path-derived endpoints are maybe not as clearly separated as you might hope.
So it also defines 3 styles of how you can actually do racing between your various options. Once you've built a list at each level, these should be relatively non-controversial, I think. You could do things simultaneously, and the draft essentially explains why you should probably never do that. You could do something based on a staggered delay, or you could do something as a failover if I really prefer this option and I only want to try the next option if my primary preference has completely failed. There's also the question of what does it mean to be established? So traditionally, happy eyeballs is something that ends once you have the 3-way TCP handshake done, and that's great. But depending on your use case, you may actually want to see, is this really a usable path or a usable connection? Am I going to be able to get my security handshake done? Am I actually going to be able to receive useful data? Maybe I'm doing zero RTT work, and so I don't want to just assume that something is going to work. So interesting questions that an implementation has to decide there. So that's kind of a summary of this draft. What I want to bring up here now is we have 2 drafts currently in TAPS that are very related on this topic. There is the neat draft on happy eyeballs, and then there's this draft. So what do they have in common? How are we going to reconcile them? I think we should combine them and only have one, but I'd like to have that discussion out here in the open. So what do they have in common? Both of them describe how you do happy eyeballs for protocol stacks. The neat one, I believe, kind of just goes into mainly that, doesn't really go quite as much into the path racing, but they have the protocol stack racing in common. They both recommend a kind of historical database of what you've previously probed or what you've previously passively learned about your various endpoints and paths, and that should influence the ordering and timing that you use. So that's a very important one. And then also it's an important observation that both of them have that the combination of what options you're allowed to use come from your application preferences, plus your system policy, plus your historical data. And so there are 3 different sources of this information. Okay, so what's different? I'll go to the bottom one first. So there's the question of, should we have this structured tree, or do we really just generate one big list and then it's kind of free for all, you let the implementation decide what to do? I'm fine making this kind of more of a recommendation. I think if you structure things as a tree, it makes certain algorithm decisions a little bit easier. The happy eyeballs timer racing between a v4 and v6 address on Wi-Fi really has nothing to do with the happy eyeballs racing on a different path, on a different interface that's happening simultaneously. If you, as an implementation, want to kind of manage those all together, you can, but there be dragons down that road. Brian, did you have something on that one, or no? Okay, great. So I think the bigger one I want to get into is there's kind of a fundamental difference in the drafts of, what's our space of things to race? So are we racing things that the application didn't ask for or not? And I think that really makes a difference in your decisions. So in the draft, what I would like to propose is essentially that we are only going to be racing between things that the application has kind of whitelisted in as my server probably supports this, as opposed to just trying to do probes because the system likes this protocol more than this other one, or we think that this one might work. For example, like if I just want to try SCTP because I want to make it work on the internet, you would likely want to try it, but then have a very quick failover because it's probably not there. That seems to be a little bit harmful for the algorithm and for the internet. And I would prefer to see it something that is more opt-in by the application. So I'll just rush through these slides. So I think it gets to the overall question of, when we're racing, what are we actually connecting to? And these connection options, they all come from either the application or they come from the network, right? So when we're doing happy eyeballs, the options we're racing between are things that DNS told us. We know that these are real options. When we're doing racing potentially between Quick and HTTP2, this is something that applications do all the time. This is ALPN. TLS has explicitly indicated someone out there knows that the server supports this. Or the application, I just say, yeah, I know I built that server for my application. It supports these protocols on these ports. So we can have vague preferences, strict preferences. How are those actually determining what we're doing? I think the vague ones are useful for tuning things, but I don't think we should be using vague preferences to infer protocols that we don't have any explicit knowledge of them existing. And so this is a bold assertion. We can talk over the email list, but I think it's an important thing to really clarify as we're going forward on these algorithms. Right, so one of the main points that we're trying to do here in TAPS is say, let's make our transport library flexible. We don't want to ossify on just everyone's just doing TCP. I think that's great. But why is this really happening? So one thing that I think that we think of a lot is that, okay, we have applications that are writing code that only worked for TCP. It only works over sockets. This is definitely true when we see the IPv6 transition problems because people wrote their code for v4 addresses only, and that's a bad practice. Is that true for why it's hard to deploy new transport protocols or get applications to adopt their code into new transport protocols? Maybe, but certain things like, I see a lot of socket code out there that it really just deals with things generically. They just have a sock stream. Isn't a stream just a stream? Couldn't I run that over any stream protocol? And so what I would like to point out here is that sometimes actually the fact that our libraries and our implementations like sockets give us these generic vague options for protocol selection, but then we end up only doing one thing beneath it in that current implementation actually led to the ossification. The fact that we say sock stream is a stream, you can just write your stream on this. But then in practice, that always meant TCP. That means that applications have been deployed, that they will get worse behavior if we start doing things under them that are stream that they never opted into. And so if we could end up deploying a TAP system, right, that says oh, great, TAPS works with quick SCTP and TCP. Woohoo. And then the applications get used to that set as being the things that are there. And the moment you try to add number 4, they have to now wait for that racing, or they're delayed, or it just doesn't work. So we don't want to get into that situation again. So we can read this online. I don't want to take up too much time here, but essentially saying that our API should work with any protocol, and we shouldn't have to change any of the application code. However, we shouldn't just be inferring things. I think it's sufficient for a lot of this TAPS work to say, all you can do is flip a configuration bit to turn on, green light this protocol, say, I support this. And that's a great goal, but we shouldn't be doing things that the applications don't expect in this racing. I think that ends up being harmful. So that's my piece.
Great. So I'll point out that on this slide, these right now seem to be slightly mutually exclusive, in that you say, okay, well, we're not going to, and I think that's bad, and I don't think it's a problem with I don't think it's a problem with the expression of the thing. I think it's a fundamental problem that we need to find a way to solve it. Is you're saying, okay, we're not going to have the library do unexpected things to you by sort of essentially greasing the protocol space, if you're familiar with the concept of greasing. Yep. But then if you have applications that are used to having to trick the API, you can't fix that without tricking the application. I don't know how to fix that. That's just that might be a fundamental problem that we have to throw some brain at.
Right. And what I want to say is that it's actually not that big of a problem to change the application. Telling the application to rewrite their entire library to stop using sockets is terrible. Right. Telling them to change a bit, like these apps, they deploy new versions all the time. Turning on a Boolean whenever they turn on the new protocol on their server end is not that big of a deal.
Okay. So basically,
Make it easy.
The application deployment and development cycle that dominated the sockets era is not the same as the current application development and deployment cycle, and we should pay attention to that. Okay, that's an interesting insight, and I'm less unhappy now. That's not the thing I came up here to say. The thing that got me in the mic line was as you were talking about what should you race and what should you not race, and should you tree it or sequence it. I think that the distinction that you're making here is something we should pull into PostSockets. It's things that the application cares about and that we know, and not that the library thinks. But one of the advantages of having a tree-oriented as opposed to a sequence-oriented thing is that you can use the same mechanism to do both current things that we know we want to do, as well as to have the library potentially, I'm going to race this PSI and I'm never going to use it because I want to know.
We actually do that.
Okay.
Like when we're trying to probe for TLS 1.3 compatibility, we spin up another tree.
Right. And then you store that information in the association for the future. Okay. Cool.
Okay, I'm going to block the line after Spencer.
Hi, Colin Perkins. So I think this has to be a tree, because you can always collapse it to a tree with just one set of branches, which gives you a sequence. And there are clearly things where you need that flexibility. In terms of racing things that you don't expect, the issue which came out with a lot of the ICE work was that you got so many candidates that you ended up congesting the link. Yeah, and exactly. people are actually trying to cut down on the number of things they're racing. So adding more into this mix, I think, is likely to be a problem. So yeah, I agree on that. On this ossification point, I think a lot of the problem is we tried to be general, but it wasn't actually general. There was only one thing there. Right. If we, from the start, have multiple options, I think we avoid, if you say stream and it could give you more than one thing, I think you avoid some of that problem. The other thing is, give an explicit way of getting a protocol, right? Don't say stream and assume you get TCP. Say, exactly. Have an option, say, I want a TCP connection.
Exactly.
I mean, it would be
to say that I want to interact with it as a stream, but the things that I allow it to use are TCP and quick.
Yeah. I want a stream, but it has to be a TCP stream.
Right. Yeah. Wolfgang Beck. most of our application layer RFCs explicitly state the protocol to be used.
Exactly.
Sometimes we have options to use different protocols, but most of the time we have use UDP for radius or use TCP for something else.
Because that's what the server supports.
Yes. We have very few, I don't know of any application RFC which simply states use a protocol with partial reliability and quick interactivity or something.
Yes.
We state the protocol because we have discussed the pros and cons of the different protocols. Another thing about the previous slides, you only talked about connection-oriented sessions, but sometimes we have things like switching from UDP to TCP.
Yep.
For example, you want to do voice over UDP, of course, but sometimes firewalls only allow TCP. And in the zip world, we have standardized this ICE stuff, which is very complex and takes a lot of time, which is bad for session setup time. And this is something you can't handle in some general library. You have to do it in the application.
So not necessarily. So I have experience with doing things like, for example, like IKE VPN negotiations run over UDP. We can fall over to TCP when we need to because there's intolerance to that. I think the solution there, that gets back to the point of how are we determining what establishment means. If you actually include some level of application protocol into that, like the application determines that I got useful work back and this is going to work for me, then that determines it. So I can use a UDP protocol, and if I determine after some time it's not working, the same algorithm for how you fall over to another path still applies. And we do employ this.
But for UDP, you have to get some reply. And in ZIP, you have the stun message.
So it's not about UDP becoming established, it's about the higher level becoming established.
I think it's application
Can we take this
dependent.
discussion offline? I'm concerned about getting through the agenda. Didn't you just?
You cut the line after
Exactly.
Spencer. I'm not after Spencer.
But it was also it was also after you.
Just very quickly following up on the ICE point and that previous comment, you may have to hook this racing into the application state.
Absolutely.
Yeah. So you're hooking into application state, like not all within the stack.
Spencer Dawkins is interested individual. The first observation I would have is not only do we have reordering problems with transport protocols, we even had them with the MICLINE and transport working groups apparently. Awesome, good job. The thing I was going to ask about, and I don't need an answer like in the next 18 months. So I'm just telling you, anytime between now and working IETF last call is fine. But I was also interested in your response to Brian about kind of what application development looks like these days compared to the sockets era. And I believe you. And I'm curious as an area director about what the tail looks like for that. And like I say, don't answer that now because the answer will change by the time, I mean, you'll be further down the tail, but I would like for that to be cross somebody's mind before IETF last call, when all the people that don't do it that way tell us that they don't do it that way. Does that make sense? I mean, is that fair?
That's a fantastic point. My initial gut reaction would be that the tail of people who aren't pushing new updates to their code are probably not going to be adopting anything after sockets anyway at this point.
And like I say, that's a fine answer if it works.
All right, thank you, Tommy.
Tommy? No, I think I'll take that question offline. But just for your information, Tommy, you take 23 minutes. See, 8% accuracy.
Okay, Gory. Oh, you want to do from here? Yeah, sure. Do you have HDMI?
Plug it in? No?
Maybe we should.
Okay. Okay, we will use this computer.
So Corey, if we're gonna have any discussion about the third document approach in the working group, we're gonna need to end this pretty sharply on 20 minutes. Questions and everything. Just setting expectations here.
Yeah, I was going to be quick with my laptop, but I shall be quick anyway. So, oh, that one. Okay. Can I work it out? This draft is short and easy to read. People have accused me of writing too much. This time I wrote too little to figure out what it is that we need to write next. So let me tell you what it's about. It's about the neat protocol stack. So it's about something that implements some of the things in TAPS with real running code. So this is a result that has generated code where we can signal things down to the stack, and the stack can make decisions on behalf of the application in the ways we've talked about. It supports a single API to transport. It's got explicit support for multi-streaming, multipath, security. It's got a policy-based selection engine in the middle, which does the happy eyeballs candidate selection. And that may be the bit that's most interesting. Currently, I don't say much in the draft, so if you want to see more about that, ask questions, or we'll write more if people want it. This is the sort of thing that Neat does. When you start an application, you set up the Neat system by initializing it, and then you pass a JSON string expressing what you might want. So here's a very general requirement you might have from the application. You want a reliable transport. Things can be either required or they can be desired. So we have both levels of functionality. If it's required, it has to be provided, or your connection fails. If it's desired, then it's something that goes ultimately into the candidate selection. Whatever the properties you request from the application, Neat proposes a set of candidates. In this case, they could be different transports. Neat performs happy eyeballs. We have a draft already on happy eyeballs and how that works. And then finally, a Neat endpoint is used for communication. And then we enter the maintenance mode where you can adjust things, but they are on a connection that's already been established. So this is a diagram which kind of shows a little bit more how it works internally, which is probably the most useful part of our draft, because this particular draft brings together the functional parts. The app indicates properties. You call a set of properties call, give it JSON. You could indicate things that require, like transport type. You could indicate properties like the DSCP value or the abstract DSCP, or something even more abstract, like you just want high throughput or whatever. Then you do an open call, and finally you can get back from the system what properties were actually set, because you need to be accountable, I think, when we define this, so that apps actually can find out what happened when you did all the magic underneath to make up the connection that you finally chose. So underneath, we have the Neat User API, which is the main topic of the draft. Then we have the Neat Logic, which is by far the biggest chunk of code. This is the piece of code that actually does things. From the Neat Logic, there's a policy interface to a policy manager, which is the piece of machinery in Neat that takes the properties input. It combines them with a policy information base, which is configuration information. This links properties with rules about how to use them, and it links them with profiles defining what it actually means when you ask for something. So it expands the property list. We also have the characteristics information base, which is learned material. You'll see synergy with the things we've heard earlier in the TAPS meeting. This is things discovered from the network. It could be path history information. It could be protocol history. It could also be explicit signaling. I'm a great fan of PVD. So if you want to imagine PVD in here, we have a way of injecting PVDs into the system so that network interfaces then become PVDs, and you can learn about the characteristics of these PVDs. Whatever, you have a shed load of information, what's configured, what was asked for, either concretely or abstractly, and the information you've got about paths. Out of this comes something. So properties come down, up comes candidates, and as Colin's already pointed out, Whenever you do this, you end up with an infinite number of candidates. So one of the things that the policy manager has to do is suggest a suitable list of candidates which come up to the NEAT system, and then it has to decide how to use these. That's a racing decision, and it's easier when you've got a connection-oriented transport and you have a connect. It's rather fiddly when you've got UDP or datagram-based transport because you don't actually have a connect. So you've got to define some notion about choosing which one. And sometimes that means you have to use this failover mode of racing because really you just don't have a connection set up. But sometimes you have a protocol on top of UDP. So this is a little bit more tricky. Yeah, you can do it then you can do the full ICE thing if you really wanted to. We don't.
Great. Who is using this policy interface?
Who?
Who is using this policy interface? Like, who is setting this up?
The policy interface is between the two parts of NEAT, the policy manager and the NEAT logic. So this is an internal interface, but we thought it was a real interface that existed, where you suggest properties and you get back candidates. The external interface is the policy info base, which is the horizontal line, and this in our system is currently JSON files.
Okay, that's the link I was missing. I was not sure. Thank you.
Yeah. The character information base also appears as JSON. So I was told to be quick, so I'll carry on being quick. Happy Eyeball simply selects, when you've got these candidates, it chooses one of these possibilities, and one of them wins. There you go. That was simple. It was easy. Lots of difficulty in actually realizing this. So what happens when you ask for something that's a little bit more abstract, maybe low latency? Low latency is one of these services you might want because you're doing a background file download, and it's a concrete application requirement. My preference is kind of for things that can be expressed by applications and make the TAPS system do something, and then the application knows that that thing is going to be done. So when you ask for low latency, you're asking for TAPS to put in the NEAT system a set of properties to implement low latency. Then the application has to decide if they want low latency, and if they do, they request that property, and it becomes a profile of things that they get. I would prefer that to try to say I want a latency less than X, or I'm trying to send this much, because these things I find very hard to actually match with things, and I've played with RSVP for many years, and I know there are many, many parameters here. Simple word goes down the stack. This is actually a profile. The profile has to be expanded by the system according to the policy information base. We get candidates back. Now we have probably two things to race. We have some notion of interfaces, preferably PVD, and we have the notion of which transport we should use. So in this case, we have decisions made at two levels. We could argue which level we do first or whether we do them in combination. This is all good fun, and I suspect in reality we'll end up with different versions for slightly different views of this, maybe different versions for whether we're doing datagram versus connection-oriented. Maybe if we have slightly more PVD information, we get heavily into path selection. But ultimately, we have to choose a path to work with, we have to choose a transport to work with, and we end up with this. So if you were clever, you'd realize I didn't talk about anything which I would put in the session layer. I believe the session layer exists. I know it's the IETF, but there are functions above transport and below apps. And yeah, there really are. Yeah, and the PostSockets API talks about this, and in NEAT, we don't talk so much about keeping such connections alive over time. We don't talk about the mobility and moving of connections between one bearer and another, or carrier in PostSockets case. This NEAT concentrated particularly on the things that we could actually implement now, and where we have a concrete way of doing it. I have slight concerns about making things overly complicated when we do this adjustment, because I really want people to buy into the TAPS API. And if we start bundling too much, I have fears. The good news is we've bundled this much so far in our project, and we're happy with this. So we can figure out how much is good. The slide says callback based. I think that, to me, is an essential part of the whole thing. This is probably a more fundamental change than any of the other changes. And it's a change that's already happened in the apps development world. So whatever we do with the TAPS API, it has to be callback based. That means when you make a read call, you're told, first of all, to go read. You read. When you make a write call, you write, and it tells you it's written. You can argue about whether it has to tell you every time it's written or whether it tells you about all of it, but you get a callback. You also get a callback when it goes wrong. Some sort of timeout goes, hey, it's gone wrong. And that's the same in Neat for all the other messages. If you want to pick up an event for something happening, you get an event call, it comes up. So this means you have to rewrite the programs in a different way. It turns out most people are already writing that way, so it's cool. Next steps. Trying to be quick. We have code, so we would encourage people to play with our code or ask us how our code works. You don't have to play with it, you can just simply ask. But you can go to the GitHub and get it. I failed to draw ASCII art by the deadline. I was fearing that the diagram looked terrible, so there's a Rev 1, if you haven't seen it, which has the ASCII art in. What does the working group do next? Which is kind of passing the buck back to you people, because I think there's space for some sort of document which is architectural and defines some API, maybe more than one API. So is that the way we go? Before I write a shed load of text, I would really love to know what sort of documents we want to produce. End.
Can you say something about the example apps that you've got running on this?
Sorry.
Can you say something about the example apps that you've got running?
I could. We could send bytes backwards and forwards. That's good. We have code from Mozilla, which runs a version of Firefox on it. It's got issues because Mozilla's Firefox is a pretty big package to run on top of it, but it sends packets backwards and forwards, and we have other apps as well.
Mia Kulevin. So I have two concrete points. So one is that this approach is like the main primitive is still a stream, and I really think it should be a message.
Well, datagrams are not streams ever, Mira.
Yeah,
and
but
no.
So, but what you kind of do is like, I assume it's a stream, and if you have datagrams, then I kind of merge this into a message. But the base primitive should be message. That's how I.
No. I agree with you.
Okay.
And
that's fine. Then we don't need to discuss any further. That's not how I.
Messages are cool. Messages are what we are.
And the second part is that I think you have today, even if you say like, I don't know, all this what we have hidden in the association is something that you don't have to do in the transport layer. I think there's already things in the transport layer that have like long-term state and that need to be covered.
Yeah, we have a long-term state as regards path information. So we keep information about what transports work, and we keep information about what latency we're seeing on paths, that sort of stuff. But what I've avoided was keeping things that we would call socket handles relating to connections we'd set up in the past, because I think that belongs to the layer above. Now, you could argue we should specify that as well.
Yeah, so I mean, like, I guess our main use case is if you take TLS basically as part of the transport layer, then you need to handle session resumption as well in that layer. But
yeah,
you can say that's above.
So we do TLS, but magic happens when you handle the keys.
Kyle Rose. So I would have a minor quibble with the way that you phrase the API, the requirement for the API model. You said event-driven. It seems like, so there are a number of different models that are used widely in different languages, right? I mean, sometimes you have an event-driven model, but sometimes you want blocking, or you want to be able to program in an imperative style, or you're using continuation passing style or something like that, right? And so I think what you want is the API to be able to express a multitude of programming models. And it may be that having an event-based model is sufficient to implement all of those. I don't know, what are your thoughts on that?
I think the event-based model has got to be the way we go, because even when you get right down to the interface, we're actually sending blocks of packets, etc. And
well, I understand. I mean, I guess the point of having an event-based model is so that you're not forcing blocking on people and you're not forcing polling. right?
Yeah. Okay. So I can't say much to answer your question, but I mean, the system we have is based on libuv. We have above this a socket shim, which rewrites it all as sockets. So clearly you can do many things above the callback-based API, including reverting back to the previous version of this world where we use sockets. So we actually have that as running code as well. So I think the callback-based API could become the basis, and on top of that, you can build other approaches if you really want to.
Do you want to respond?
Oh, yeah.
I can.
Go for it, Tommy.
Tommy, sorry for cutting in line. I think the main point is that we don't want blocking APIs to be the native thing. But I mean, event is one way to do asynchronous. You can have completions. Like there are many models for asynchronous. I think any of those are on the table. It should not be one model of asynchronicity that works here. And yeah, they're pretty much equivalent.
Well, well, the thing is that there are existing applications that are developed in a specific model, right? And so some are going to be using continuation passing style, some are going to be using event loops, some are going to be doing other things. And it would be good to make sure that whatever the API here is can support all of those models. And so I think and it may be that an event-based system is perfectly sufficient for that.
Right, and I recognize that like in the NEAT document, especially in the NEAT Happy Eyeballs document, it actually goes into a fairly detailed discussion of the libraries that are being used for eventing. That's fine for an informational, but I think anything that is produced as this is an abstract API should absolutely not have any reference to how the implementation should do it for asynchronicity.
I'd second that because you have to compose this network interaction with other interactions like from the GUI or something. Generally, when you use callbacks, I want to use an application data thing in my callback and not just the written data or the received number, because else I have to use globals. And the other thing was, no, I forgot it. Sorry.
Okay. That's fine. And I think we should have this discussion going on. I mean, one of the things I was trying to say was we did it all in this way. We also did the socket layer manipulation on top, which reverted to sockets. I guess the way in which Mozilla actually code their internals of the product isn't something we want to talk about, but it's not quite the same as the way in which we envisaged it. So there's yet a third way that the API is being used.
My second point was about this low watermark stuff where you can limit the queue size, but the queue size itself doesn't tell me very much because I don't know how fast my connection is. What I really want to know is what Van Jacobson called the packet sojourn time through the queue. You can do this today with the socket API if you have the buffer occupancy and the last received acknowledgement number, then you can calculate the time the last packet used to traverse the queuing time, and then you can get some estimate if your message will arrive in time. And that's somewhat missing here. So a way to determine the actual time my packet stays in the queue.
You're a real-time person, yes?
Yes.
The question kind of looks like it's framing sort of packets on the wire for a multimedia or something, which is an application where you really want that sort of functionality.
My use case is the zip proxy. We had this problem in the wild, where the zip request is in the TCP queue and times out before it gets sent.
Yep.
So
yeah, sure.
Gauri, this draft talks about this policy manager, and there has been other discussions like racing and API ball and some other discussions here. What's your thought on that and policy manager? Like, how do you see, like, I mean, do you see like this is a essential part of this draft that you talk about it, or you see like this draft can refer to some other things that, I mean, it was not clear on the policy manager, like how you need to use that.
Okay, so so I see Happy Eyeballs as two parts. I see one part that generates a list of candidates, tree of candidates, however you wish to express it, not all of which you will try, and then a method for trying them. So in my own thinking, I see the Happy Eyeballs as how you choose amongst the list you've given. But then there's the question of how you generate that list, because that list also includes preferences for bandwidth or cost or protocol or reliability or maybe timing, etc. So there's another bit in here and how that interfaces with the stuff that's configured versus learned versus accepted from the application. So that's the bit where the policy manager fits in. And I drew it just as a big blob. I didn't say what it was, but that's kind of what it is. Is that something we want to define here?
Well, I think we're discussing some of these things here, like with intents and post sockets and racing. So obviously there's something that we're gonna anyway talk about.
Yeah.
And I'm just like confused about like whether this is a fit to the draft or it should be something else.
Yeah, maybe my final point, since you keep to come back again and give me another chance, is maybe we're beginning to reach the point where we want some sort of architecture, which is why I tried to draw big boxes on my diagrams. If we can come up with an architecture we can all agree on, then maybe we can start precisioning the language we use for these things, and maybe it'd be slightly more agreement if we had the same language.
Thank you, Gori. That's actually a really useful point. So the next agenda item is to talk about the document number 3, or milestone number 3. When we wrote the charter, let me say something before you comment on it, Brian.
Yeah.
Just give a moment.
From the mic.
Something. Just give me something here. So when we wrote the charter, personally, the model in my mind was we were going to spend a bunch of time wandering around, looking at existing protocols, trying to abstract stuff that was going on inside of them. There was a lot of interest and energy in sort of coming up with a happy eyeballs equivalent for transport protocols. And so the text that came out of that discussion was, after we come up with MinSet, was, oh, well, we'll do some experiments. We'll build some stuff. We'll write some documents that describes what we built. Then maybe we'll recharter. We could certainly do that, right? There are several activities going on. I'm actually personally extremely excited about the level of energy and the fidelity of the work that's happening in this working group. I think it's, I was a little depressed for a while when the group was kind of quiet, but you guys have really kind of lifted my spirits. But I think that Gori, I think, summarized it rather nicely, which is, you know, we could go and start writing RFCs about the stuff that people are doing, or we could try to come up with an architecture that maybe synthesizes some of these pieces together, and then write some RFCs that reflect that. I think there's a really interesting combination of perspectives here between sort of the NEAT perspective and the post-socket perspective, and that, you know, NEAT is very much supporting the existing technology suite. Post-sockets is trying to come up with something that will support stuff that hasn't been invented yet. There's a lot of commonality between them. I think there's a lot of agreement. So my gut tells me that there is an architecture that can be extracted from this, but ultimately it's going to come down to whether people in this room want to work on creating that. It may be that you know, maybe people would rather just build their own stuff. And so I don't know if we're going to converge on that today, but I'd like to hear a little bit from the folks in the room about what you think you'd like to do. I mean, do you want to start, if we're going to start taking a milestone 3 the way it's written now, I'd say we've got a set of candidate documents. We can take those in as working group documents, and they'll be published with a title like something like TAPS candidate, you know, post-sockets, TAPS candidate, NEAT, TAPS candidate, you know, protocol racing or something like that. And just, you know, there'll be sort of snapshots of a bunch of research work in progress around this general problem area. Or we can try to tackle the nut, which is, you know, how do we push these kind of interesting perspectives together where there are some obvious tensions in them?
Hi, Brian Drammel. Would it be problematic for you to put like my 4th slide back up? Would that be easy or hard to do?
Let's find out. Keep talking.
So I agree with you that that's the choice before us, is that we could basically say, okay, well, this is the, you know, we're doing experimentation with post sockets right now. We intend to do much more of it, and we could basically frame this as, yeah. So the 3rd slide, yeah, that one, number 3, not number 4. Show proof with soft proof with proof. That's not what's that even for? Go one back. Sorry, 3rd slide, not 4th one. But I'll point out that that's basically an architecture, right? those are relatively high level boxes, each of which can be implemented. I mean, like each of which can be implemented within the system in a given way, but it's the most abstract API we can come up with that still says something. And it basically, you know, this right here is an architecture that you can hang the rest of this off of. Now, whether or not it's the TAPS architecture or not, I mean, obviously, when something's under working group change control, you know, we discuss about it and we tweak it and we change it and we, you know, put different multiplicities on the lines and we change the colors and stuff and whatnot. But I would point out that we basically kind of already were there, right? So that's the start of an architecture.
So I would be pleased to hear whether people who are working on other projects agree with your statement. That this
As
is
would
an
I.
architecture that makes sense to them, that their stuff
Yeah.
can fit inside.
Yes, cool.
So feel free.
Those people
or
aren't in
you
the
or
line.
Michael to opine on this.
Yeah, okay.
Mia Kulevin. I'm not working on another project, but I'm not sure if the word architecture is actually the absolutely right word. It's probably more a framework or whatever. But the main point is this is on a higher level of abstraction than the need interface is. I just wanted to say the need architecture. So it's not that it's like one or the other. It's just a different level of abstraction, and we should decide which level of abstraction we want to document. We could even do both. I'm not sure if that's useful, but that's a decision we have to make.
I think if we do both, we either have to say how they're connected, or we
Yeah.
say that these are two independent activities.
No, no. I think
Connection. So we-
I really think they should be connected. I don't see them as independent. It's
That's,
yeah.
I would like somebody from NEAT to agree.
Michael Wessel, I'm here for 2 points. First, answering the request on somebody from NEAT saying, well, what they think about this. I think it's a useful architecture. I agree with that as an architecture. I agree with how Miria says that being a higher layer. Another point of why I actually went here is that the way you talked about the third item, we could basically, you know, if we would leave it as the charter is now, it could just be more or less done with the documents we have now, if I read this correctly. I would disagree with that because the point of the third charter item, at least this was my interpretation, is that this is about how you would actually implement that stuff. And the current documents, yes, I mean, happy eyeballing is one part of it, but it's only one part of it. There is more. So I think we really need documents explaining how to implement that stuff. And I mean, I appreciate this being good, but that's not all that needs to be.
Yeah, I'm sorry if I was not trying to say that an architectural document satisfies Charter Item 3. I was saying that you know you could talk about implementations and the designs of those implementations without talking about architecture and without connecting the implementations together in some coherent fashion. And I think that this is an approach for doing that. But it'll take some work from everyone involved to sort of like mash their stuff in so it fits into this model so you can see how they're related.
Right.
I think that would be a useful thing. I also agree, as the questions like I was asking Philip earlier, I think implementation experience is extremely important for validating some of these ideas.
Right.
All done. Okay, we have 3 minutes.
Gori,
I'll try to
first.
shut up.
Full disclosure, I work in both projects. So, but I see this more as a framework, and I see the post-socket stuff as higher level. Okay.
You don't see them as being incompatible in any way.
I don't see them as incompatible, but they are different levels to look at the problem, and whether we want to look at both levels or whether we want to collapse it into just one, I don't know.
Anna Brunström, so I work in NEAT. I agree that we should try and merge and have the connection between them. I think that maybe we need something that is, I think this is a good starting point for the architecture. Maybe this is a little bit too abstract, and maybe NEAT is a little bit not enough abstract. So if we just want one API, maybe it's a little bit somewhere in between.
Tommy Pauly, Apple. One, I do think this probably seems like we should be rewording Charter Item 3 either way, so that should happen. I think with the terms of like, do we have implementations or do we have architecture? I think if we just stop with the implementations, that's interesting, but that's essentially what we have today, and we have a good amount of experience. I think we have enough experience in the room from various implementations. I also think from people who aren't speaking up to give their examples of how they do this. so I've been working on the post-socket stuff. This is agreed at a very abstract level. I think it could be very interesting to say, let's all come together, work on the abstract definition. There's a neat implementation document, like here's how we decided to express this. I could write a document on how I have decided to express it. And we call it all maybe something like post-socket or something abstract on top of that, with various levels of how to implement this depending on your system. And that way we have both something that's like I think what I wanted to get out of post or a high-level architecture is something that is forward-looking enough that it doesn't become irrelevant in 10 years. But then we also should have things that are concrete enough that someone can implement them now. And those are two prongs that may end up with different documents.
Yeah, I didn't think we were going to have the architecture piece, so I'm actually kind of happy that that it looks like these things are fitting together. Okay, quickly.
May I could have in again. So I also want to make one comment that we've been going here a bottom-up approach. So we've been analyzing what's there, how can we generalize this, and then going up. But I believe that somebody who reads the TAPS documents later on, this document would probably be the starting point, and you would start from the more abstract to the general thing. So that's something we should keep in mind when we try to align things.
So I already see that the whole post sockets need the socket intent stuff. Everything, the people are now going towards a common language and trying to at least find a common language. And I think this is the way how this can merge. But I think it has to do, to merge in the separate documents and then converge to something later on with a common language we later on have. So I would rather be for keeping it separate and trying how it merges over time with the experimentation, with the experiences, and then find out over time what makes sense, what's the right abstraction. I think we will see this later. I think we can't decide this now.
Yeah, I think that's a reasonable point.
Just one thing in response to that, Tommy. I think one thing that could help speed up that process or make it easier, and we had mentioned this earlier, was to have maybe a terminology document, right? Because we have a great survey of transport protocols, we have a great min-set stuff, but there are these words that are floating around that lots of people have different meanings behind, of paths and endpoints and connections. And maybe just having one terminology document that all of these other ones, implementations and abstract APIs, can reference, so we don't have to worry about the differences there and get confused, would really speed up the process. And I think we would end up realizing what we have in common much more quickly.
Yeah. Somebody want to raise their hand to submit a draft for the next meeting? I think the bar is low, just terminology, but a lot of it could be copy and paste from other stuff. Was that a thumb or was that a whole hand, Thomas? All right, I think we'll probably have to take this to the list. We don't have time to talk about it now, but maybe we can have some hallway discussions this week and see if we can get some folks together. I think this was a really productive discussion. Thank you, everybody, for waiting it out. If you didn't sign the blue sheets, it's my bad for not nagging you about it. Please do it. Those numbers are actually useful when we pick the room sizes for the next meeting. So if for no other reason, if you want to have a seat in London, sign the blue sheet. Thank you, everybody. We're done. All right.